All right, let's take a look at number 10. So number 10 is saying, let the domain of X be all students, define all predicates P of X, B of X, and D of X as follows. So we have that P of X is X practices two other concepts, B of X is X believes in themselves, and D of X is X will do well in the exam, which you guys all will. So every student who practices 203 concepts or believes in themselves will do well in the exam. Right, so how do we do this? Right, let's just not even look at the choices first, right? How do we do this? So we have every student, right? Which this is gonna be what? This is gonna be a for all, right? So every student X who practices two or three concepts or believes in themselves will do well in the exam. So basically we need an if then. We have an implication, right? Everyone who does this, meaning if they practice this or believe in themselves, they will do well in the exam. So it'll kind of look like this. So everyone who practices, so that means if they practice two or three concepts or believes in themselves, so it's gonna be or B of X, will do on the exam, D of X. So this is what we have, and let's go through each choice and see which ones are logically equivalent. So of course, A doesn't work because we're not using an if and only if, right? We only have an if then, right? We have people who practice two of the concepts or believe in themselves will do on the exam. The other way around, we're saying people who do on the exam not necessarily have to have, done the two or three concepts or believe in them or themselves. So based on our proposition, A is correct, right? It's just identical to what we have over here. Let's take a look at C. C is saying for all X, not P of X and not B of X or D of X. Right? What this is if we take a look at this is just implication breakout of this, right? But here, if we want to do implication breakout, it's equivalent to saying A of X for all X, right? We have not P or Q, right? So we have not P of X or B of X, right? Or D of X. And if we want to apply De Morgan's inside here, then what we get for all X, uh, P of X, not P of X, and not B of X, in parentheses here, or D of X, giving us choice C over here. For part D, let's take a look. How do they get here? Maybe we can put another double negation, right? Because we learned in class that, not P is just equal to P, right? It's like a double negative. So what if we try that over here? So why don't we do not for all X over here, right? So we put it up over here. What does that do? Let's move one of them in. So we have not something, right? So this over here, the for all turns into there exists. And then we have to negate the entire thing here. So we have to negate this and this, right? So it'll be not P of X and not B of X. Oops, there should be a little thing over there. So not this, like that. And then if you want to, distribute it again here, it'll be and not D of X, right? And now if you want to distribute this around inside using De Morgan's, then we'll basically get this over here, right? Because we get something like there's not exist, this will cancel out, so it'll be P of X, the and will flip to an or, and then not B of X is just gonna be B of X and not D of X. So that's where D comes from. What about E? E is saying there does not exist X such that D of X and not P of X and not B of X. So this doesn't look like logically equivalent to anything we have over here. And turns out that this over here is actually just the negation of this entire thing. So this one doesn't work. This one is not logically equivalent to any of these. there's really no steps you can take from anything over here or here to get part E. So final answer is going to be B, C, and D. B, C, and D.